All right, ladies and gentlemen, we're ready to get into redox reactions. We kind of already talked about this in class. We did a poster on it, and we did it on a quiz. Redox reactions are probably, they can kind of be easy and they can kind of be hard. You just have to really pay attention, okay? So, messed up on that one. So first thing we need to do is we need to define it. So an oxidation-reduction reaction is when electrons are transferred from one species to another, so from one substance to another, okay? Oxidation and reduction always occurs simultaneously. That means that if one is oxidized, the other has to be reduced. We use oxidation numbers to keep track of electron transfer. So that right here is the biggest key, is that it has to have oxidation numbers and they have to transfer, and we use oxidation numbers to keep track of where they go. Remember to make sure you write all this stuff down in your notes, because you're going to give me a summary when you come back, and you're also going to have some questions to do at the end. Okay, so rules for assigning oxidation numbers. The oxidation state, and this is very, very, very important right here. Sorry, I forgot about that. The oxidation state for any free element, we talked about that in class, the free element is always 0. They are elements, okay? And nothing else is attached to them. They can have, however, be diatomic molecules, or O3, which is a different kind of molecule in itself. Okay, the oxidation state of an element is simply the ion that is charged to the ion. So like, for instance, magnesium, M2 plus is the oxidation state. So that's why I've been calling them charges and then also calling them oxidation numbers, because the number that we assign to them is the oxidation number, okay? And metals are positive, nonmetals are negative, usually, okay? So rules for assigning oxidation numbers continue is any neutral compound has a sum of 0. That's kind of why we do those ionic compounds, and we were trying to get to 0 so that we don't have any charges on them, okay? All right, so polyatomic ions, we're going to basically use a charge that's given on the chart, okay? Oops, let me go there. All right, so here's some other rules. Use these rules to assign oxidation. Assign the numbers first, and then fill the ones that you know first, and then fill in the rest. So what does this mean to us? And we're not going to use this too often. Oops, let me go back. Not going to use this too often, but in NaNO3, we know sodium is a +1, and we know oxygen is a -2. So therefore, we have to have a +5 to have an overall negative charge. How does this work? Well, this has a +1. This has a -2, and there's 3 of them, so that would be 3 times 2 should give us 6. So we have a -6. We have a +1 and a -6, so the only thing left that we have to have a 0, because there's no charge attached to it, is a +5. Okay, just kind of keep that in mind. I think there's a couple of them that we do that you have to kind of figure out something. Okay. All right, so definitions. Please pause this and write this down. These 4 things are really important to us. Oxidation is the process of losing electrons. So if we're losing electrons, we're becoming more positive. And reduction is a gain of electrons, so we're becoming more negative. And then oxidizing agents are the species or the substances that are going to be causing the oxidation, so they're going to get reduced, meaning they're going to get negative. And reducing agents, the ones doing the reducing, are getting oxidized, so they're getting more positive, okay? So if you need to, stop the video. Okay, so here's an easy way to remember this. Oil rig, and definitely write this down. Oil rig, oxidation is a loss of electrons, and reduction is a gain of electrons. And remember, electrons have a negative charge attached to them. You can also do Leo the lion goes grr. So that's Leo the lion goes grr. Okay. Losing electrons is oxidized, gaining electrons is reduced. That's what Leo the lion goes grr. Okay. So all reactions are all reactions redox? No. That we have to figure out what they are. So we're going to start with redox because it's kind of the easiest ones to figure out. Here's an idea. If you have a free element, then you have oxidation reduction or redox. Redox. So if you look here, because this started out as a 0 charge, and over here it becomes a +2 charge, this now became more positive by 2, so this zinc became, zinc is the one that became oxidized because it's oil rig. Oxidation is the loss of electrons. It lost electrons, so this is the oxidized. Okay, oxidized. And then what was reduced? Well, copper started out as a +2, and over here it became 0. So what happened is it gained 2 electrons, and remember, gaining electrons is reduced. Okay, reduced. Okay, that's how we know. And then this sulfate, it was a -2 here, and it's a -2 here. It did not do anything. Okay, so let's go down to the next one. All right, so these examples, I want you to write these in your journal, and I want you to tell me if you think it is reduced, or I mean, if it's a redox or non-redox. Then I want you to write this one, and same thing, and this one, same thing. Now the key here, and I'll go back, the key here is we need free elements, okay? Free elements. So here's your first one. Do you see any free elements? Here's your next one. Do you see any free elements? And here's your last one. Do you see any free elements? Pause the video where you need to, bring it to class. Have a good night.